So for the second lesson, we're going to learn about special angle triangles. And generally in the past, when we had a little bit more time, we would do a little investigation using squares and equilateral triangles, but we're not going to do that. I'm just going to tell you what's happening. Actually, I'll do the investigation for you. So imagine that we have a square over here, and every single side length has a measurement of 1 unit, 1 centimeter, 1 meter, doesn't matter, it's 1 unit. If I were to take this and if I were to split it down like this, I would end up getting this type of triangle. So this triangle then would be, this measurement would be 1 unit, this measurement would be 1 unit, and to figure out the hypotenuse, we would use Pythagorean theorem. So if I were to try to figure that out, I would go 1 squared plus 1 squared is equal to c squared. Actually, I'll just do it up here. So remember, a squared plus b squared is equal to c squared. 1 squared plus 1 squared is equal to c squared. This is going to be c squared is equal to 2, and c is equal to root 2. So that means this right here is root 2 just based on Pythagorean theorem. This triangle that I have shown you is a special triangle that you're going to have to memorize, and it's called the 1, 1, root 2 triangle. Now, it's missing a really important point, and that's the angle. So let's just talk about the angles. Imagine that every single one of these angles is 90 degrees, right? Because it's a perfect square. If I were to split this up into half, what would the angle over here be now? And what would the angle over here be now? Also 45. Good. So the other part of this is 45 degrees and this is 45 degrees. Okay, so that's the first special triangle that you will have to memorize. Let's look at the second special triangle. For this one, I have an equilateral triangle, and I'm going to say each one of these side lengths is actually 2 units. It could be 1, but I don't want to deal with fractions, so I'm going to say it's 2 units. Does anyone remember what the angle measurement of an equilateral triangle is? Yeah, it's going to be 60, right? So 60 degrees here, 60 degrees here, and 60 degrees here, because they all have to add up to 180. Now, let's say I'm taking this triangle and I'm splitting it down the middle to get this triangle over here. So it's kind of the half of an equilateral triangle. So what are my measurements going to be? Well, this is going to be 2 units. What's the base going to be? If I started off with 2 units, I split it into half, it's going to be 1. And then we're going to do the same thing. We're going to use Pythagorean theorem to figure out the third. So a squared plus b squared is equal to c squared. Let's just call this a. A squared is equal to c squared minus b squared. 2 squared minus 1 squared. This is just going to be 4 minus 1. A squared is going to be 3. And so a is going to be root 3. Oh, it doesn't matter. You can call it a or b. And the point of this is telling you that this is the square root of 3. What's that? C has to be the longest side, and then the other 2 are interchangeable. You can call them whichever one, A or B. Okay, now let's talk about the angles. Well, the 60 degrees doesn't change. That's still going to be 60. And then if you take 60 and you divide it into 2 parts, you're going to end up getting 30 degrees over here. So this is your 30-60 degree triangle, and the side lengths are 1, 2, and root 3. So what was the point of all of this? Well, the point of all of this is basically the investigation that some mathematician conducted to get these very special triangles that we use in math. And I've drawn them again out for you here. And this is something you're going to have to memorize. And memorizing it does take a little bit of practice because it's so easy to mess everything up. What's a strategy I use? Well, the 1, 1, root 2 triangle is pretty easy because both the side lengths are 1, 45 degrees and 45 degrees. For the 1, 2, root 3 triangle, you're going to notice it's not in the same direction. And you should be really used to, regardless of what direction I give you the triangle, you should be able to fill in the information. So don't get used to memorizing it only in one way, because on a test, I could literally give you a triangle and draw it like this, and you should still be able to figure out where all the different things are, okay? So orientation, just don't get thrown off by that. How do I remember this? Well, I always remember that 2 is my longest side length. It's my hypotenuse. And then 1 is one of the adjacent side lengths, and 60 degrees is always in between. And for some reason, that's just how I memorized it a long time ago. And I always remember 1 and 2 has 60 in the middle. Whatever strategy you guys want to use to memorize them, you can. Just make sure you have everything in the right position so you don't get the questions wrong. Let's practice using these special triangles to fill out this chart. This chart is saying we have sine over here, and you're basically going to be putting in an angle for, like, you're going to match them up. So for example, this first one, I'm basically asking you for what is sine 30 degrees, but we're not going to be using a calculator for this. And in fact, this trig unit is kind of tricky because part of it you can use a calculator and part of it you can't. So that's why I had to split up the quizzes, because on Monday's quiz, you will be using a calculator, but on Thursday's quiz, you will not be using a calculator because I'm going to be testing you on if you've memorized the special angle triangles. So sine 30, we're just going to go to the triangle that has 30 degrees, which is this over here. Sine is opposite over hypotenuse. So it's just going to be 1 over 2. Sarah, question? Ooh, that's interesting. So again, we like always used to run into this problem. Okay, so for the next one, we're gonna go ahead and figure out what sine 45 degrees is. We go to our triangle with 45 degrees. It doesn't matter which 45 you use, you'll still get the same answer. So let's say we're doing this one. Sine is opposite over hypotenuse. So it's going to be 1 over root 2. Now, do you guys remember in our radicals unit when we learned to rationalize the denominator? Okay, if you don't remember it, basically, whenever you have an answer with a rational at the bottom, that's really poor form. So you may not remember this, but remember, why am I saying remember? We used to multiply the top and the bottom by the same radical because that would give us root 2 over 2, which is the same thing. It's just now rewritten in a way where there is no radical in the denominator. Okay, so I will remind you when you have to do this, and we're going to do it right now. So 1 over root 2 can be rewritten. So we have 1 over root 2, and that's the same as root 2 over 2. Now here is a great example. If you were to type in, like, go ahead and do sine 45 on your calculator, you get 0.7071. But if I give you this quiz and I say, don't use a calculator, and you give me 0.707, the answer is going to be wrong because I expect you to give me root 2 over 2. And that's sort of our check to see if you're doing it correctly or not. Okay, I'll do the next one with you, and then you guys can go ahead and try the rest. Sine 60 degrees. We're going to go to our triangle that has 60, which is this one over here. Sine is opposite over hypotenuse. So it's going to be root 3 over 2. And again, that's an exact value. If you try to use your calculator, you would get a very messy decimal, and then you would get the answer wrong if I'm asking you not to use a calculator. Go ahead and do the same thing for cos and tan, and then check your answers with mine. Question? Because we rationalize the denominator. So I did the work on the yellow on the side. It's poor format to have a radical in the denominator. And we learned this in the second unit, like when we were learning radicals. I know it was a long time ago. So we just multiply the top and the bottom by root 2. It's just another format. It's kind of like having a radical in the denominator is kind of like leaving your answer as 3 over 6. It's not simplified. Yeah. Or like leaving your answer as 5 to the power of -1. Exactly. For lesson. Okay, so for question number 1, it says determine the exact value. Whenever you see the words exact value, it means put your calculators away. You will not need them at all for each trigonometric ratio. So we're definitely going to be using our triangles. Sine 60, I locate 60 degrees and I say sine is opposite over hypotenuse. So it's going to be root 3 over 2 times tan 30, I locate 30, and tan is opposite over adjacent. So it's 1 over root 3. By the way, if you're doing a calculation with these, you don't need to rationalize the denominator right now. Like you can leave it as 1 over root 3 until you're done doing all your calculations. And then at the end, your final answer, you can rationalize it. Now, this follows just regular like algebra rules. If you have root 3 at the top and the bottom, you can actually cancel those out and you will end up with an answer of just a half. Let me guess, Jeff, it's dinner time. You can totally eat it. I'm good. I get you. Was that an okay example? Okay, let's keep going. The next one, we have bed mass. So we're gonna do what's inside the bracket before we do exponents. Cos 45, so you're gonna go over to the 45 example triangle. Cos is adjacent over hypotenuse, so it's gonna be 1 over root 2 plus sine 45 is going to be opposite over hypotenuse. So just locate it in your triangle, opposite over hypotenuse. It's going to be 1 over root 2 all squared. 1 over root 2 plus 1 over root 2, the denominators are already the same. So all we're going to do is multiply the numerator or add the numerators. It's going to be 2 over root 2 squared. Okay, 2 over root 2 times 2 over root 2. If I want to just expand that, it's 2 over root 2 times 2 over root 2. What we end up getting is 2 times 2 is 4. What's root 2 times root 2? Good. So our final answer is just a whole number 2. So look back at the question. Like it seems super complicated, but once you use the special angle triangles, the answers end up being really, not that they will always be nice whole numbers, but okay, go ahead and actually, no, we should do that one together as well. Okay, for the next one, now we're dealing with those pesky secondary trigonometric ratios. So how are we going to do that? Well, I kind of told you that they're not the most useful. I mean, you could figure out cotangent 45 is just adjacent over opposite, or you can rewrite it. It's kind of up to you. Okay, so I'll show you one way and then see if it works. Cotangent squared of 45 degrees is actually the same as writing it as cotangent 45 degrees, all of it squared. Okay, so you're basically finding the answer for that and then squaring the whole thing. So if we can recognize that cotangent is adjacent over opposite and cosecant is the hypotenuse over the opposite, then we can actually go to our triangles and just read off the numbers according to this set of rules. So cotangent 45, I'm going to be using this over here. And I'm going to figure out adjacent is 1 and opposite is 1. So you have to be really careful. Adjacent is just 1 and opposite is just 1. So this is going to be 1 over 1, all of it squared. Let me pause here for a second. So cosecant is the same as sine theta, but we're not using sine right now. We're using cosecant. So cosecant theta is the same as sine, but it's the opposite. So it's going to be hypotenuse over opposite. So you go ahead and find 30 degrees, which is over there. The hypotenuse is 2 and opposite is 1. And then the entire answer is going to be squared. Now we just solved this. This is 1 squared. This is minus 4. And our final answer ends up being negative 3. This is one way of doing it. I can actually see a couple of others, but I feel like this is probably the easiest, least complicated way. Questions, Surka? So another way to have done it is, do you mean flip it around like this? Like write it as 1 over tan squared 45 degrees? You could have done it that way. And then you would have still gotten the same answer, because then this would be 1 over, and then tan is 1 over 1 squared. And then for cosecant, you could have done it as 1 over sine squared 30 degrees. You could have done it that way too. Yeah. That's a little bit longer, yeah. But yeah, this was fastest. Okay, last question. How are we going to solve these things? Okay, so use the appropriate special triangle and determine theta if theta is between 0 and 90 degrees. So sine theta is equal to √3 over 2. Let's go to our triangles. First of all, in which one of these triangles can we find √3? 45 or 30, 60? Yeah, it has to be in the second triangle. It has to be in the 30, 60. Now, sine theta is √3 over 2. I know that sine theta is opposite over hypotenuse. So we have to figure out for 30 degrees is opposite over hypotenuse √3 over 2, or for 60 degrees is opposite over hypotenuse √3 over 2. So let's try 30. For 30 degrees, just completely erased everything. Okay, so for 30 degrees, sine is 1 over 2. It doesn't work out. For 60 degrees, sine is √3 over 2. So that's all you need to do. I don't know why I gave you guys so much space, but so opposite over hypotenuse. So that means theta is just going to be 60 degrees. That's it. Now, secant theta, you could solve secant theta, or what you could do is you could change it to cos theta is equal to 1 over √2, which might be a little bit easier if you want. Now, cos is adjacent over hypotenuse. So we're going to go to our special angle triangles, and we're going to see which one of those angles gives you an adjacent of 1 and a hypotenuse of √2. So go ahead and take a look at your triangles. First of all, you can eliminate the fact that the 60-30 triangle. You definitely have to use this one because it's the only one with √2 in it. And then 45 degrees, either one of those is going to give you 1 over √2. So theta is going to be equal to 45 degrees. Not too bad, right? On to the next one. √3 is a coefficient here. So in order for us to get rid of it, we can actually divide both sides by √3. So this is going to give me tan theta is equal to 1 over √3. This is like opposite over adjacent. √3 is only available in this triangle over here. Yeah, the 60-30. So which one of those, 60 or 30, gives you tan to be 1 over √3? 30 degrees is correct. So theta is just going to be equal to 30 degrees. And then the last one, you have to do a little bit of algebra work. We're going to move the -1 to the other side. So it's going to be cosecant theta is equal to 1 plus 1 is 2. I'm going to change this to sine theta is equal to 1 over 2. And remember, sine is just opposite over hypotenuse. So look in your triangles and see which one of the triangles gives you opposite of 1 and hypotenuse of 2. Well, the only hypotenuse of 2 is in the 30-60. So is it 60 or 30? Good. So it's going to be theta is equal to 30. Yay! Oh, record time. Let me tell you what you guys are doing for homework. Well, first of all, there are some textbook questions that you can try. And then handout E is what I have given to you in the other page. So I'm just going to show it to you guys at home. You guys can try this. So handout E, this is, I'll show you this. This is page number 1. Okay, page number 1, and then this is page number 2. Hold on, I want to show you the answers too. 1 second. There you go.